Hello everyone, welcome to the second part of the Winding Up activity for Math CEO. This part is called Counting Outfits, and the main goal of this one is to continue reinforcing the combinatorial thinking that we've been practicing all quarter. So we dive right into it. We have a sort of setup. We have a colorful week. We have 5 hats, 5 shirts, and 5 shorts. And each of them come in different colors. So like there's a black hat, a blue hat, a burgundy hat, a beige hat, and a bronze hat. And the same thing for the shirts and the shorts. So we want to count how many possible outfits you can choose given certain restrictions. So, for example, without restrictions, can we say that there are 125 possible outfits? Yes, because you have 5 choices for a hat, times 5 choices for a shirt, times 5 choices for shorts. Okay. And then the questions sort of slowly increase in difficulty as you go down the line. For example, Tuesday you won't repeat any colors. How many ways can you dress? Well, you have 5 choices of color for a hat, 4 choices of color for the shirt because 1 removed from the hat, and only 3 choices of color for the shorts because you don't want to choose a color from the shirts or the hats. So the big thing for this activity is to recall the strategies for tackling these problems. So things like tree diagrams are really helpful. Using sort of tables of options. Maybe even just starting to list different combinations can be really good. Or you can do what I did, sort of verbally, which is you can sort of, discuss the number of choices at each step, which is kind of like doing the tree diagrams, but with words. And so really reinforcing these strategies is going to hammer home how students can start thinking about these problems. And I also recommend you think about some of these problems as well to try to practice this thinking that you'll work your students through. The last one is very interesting. You want to create your own rule and count how many worlds are possible. It can be really easy to make a rule that's very difficult to count. But even if it is difficult, there's still ways that we can tackle it using some of these strategies. So here's a few different options. So you could try things like, how many ways are there to get dressed so your hat and your shirt are not the same color? Well, there's different ways we could think about this one, but maybe we could just verbally say that you have, say, 5 choices for what color hat you want to pick, and then after you've picked the color of the hat, you have 4 choices for the color of shirt that you can pick. And then after that, your shorts are unrestricted, so they have 5 choices as well. It doesn't matter what you did for the shirt or the hat. And so if you do this, I think the answer should be 100. Okay, so that one was okay. But there's a second one that I came up with. How many ways are there to get dressed so either your shorts or your shirt is blue? So maybe you really like blue, and you want it to be one of your big garments, right? So how many ways are there to do that with this setup? Well, this one's a lot trickier. And I think that the best way to do this one is with a tree diagram, which you can kind of see down here. So I've made this tree diagram, and the first level, I've done something unconventional. I've made a choice. I've decided one way I'm going to decide the shirt is blue, and the other way I'm going to decide the shorts are blue, and I'm going to just break it up from there. One of them should be blue to count this, so just pick one of them to be blue and go for it. So the shirt is blue, and then you can choose from there your shorts color, and then from there your hat color, and we get our usual sort of tree diagram. There is a wrinkle to this one, though, which is that if you just count up all the ends of the trees, you're going to get the wrong answer. And that's because this branch here is exactly the same as this branch here. You can double check. Like shirt is blue, shorts are blue, hat is blue. It's the same thing as doing shorts are blue, shirt is blue, hat is blue. So these are actually double counting. So you only want to count one of these branches because otherwise you're counting the same outfits twice. And so if you add all these up and remove the fact that you're double counting, I think you'll end up with the answer 45. So this question is really tricky because if you try to just tackle it without writing anything down or using any sort of technique, you might get really turned around or you might get the wrong answer because you double counted. But using one of our strategies, like drawing the tree diagram, we can really make sure that we've got, we're on the money with these numbers. So the meat and potatoes for these activities is to continue reinforcing the strategies to solve these problems.